Let's take a look at problem 6-2. In this, we have 4 independent cases given to us. There are different applications of time value of money concept that you've been learning in chapter 6. They've asked us to use the appropriate interest tables and to provide the solution in each of these following situations by computing the unknowns. So in the first one, they're saying, what's the amount of payments that Ned Wilslow must make at the end of each of 8 years to accumulate a fund of $90,000 by the end of the 8th year if the fund earns 8% interest compounded annually. So I know I have 8 years, 8 payments. Interest rate is 8% per annum. The payments are at the end of the period, and the 90,000 is a future value. So future value equals payments times the factor. So in this case, I know my future value is 90,000. I have to find out the payments. This one is unknown to me. So I'll just copy that over. The factor, which table will I look at if I'm looking for the future value? So I'll pull up the table over here and I'll show you where I'm getting the factor from. We scroll down to table, in this case up to table 6.3, future value of payments. I'm looking at 8% for 8 periods, future value of an ordinary annuity. I pull out that number over here, and that number is 10.63663. Now I have in the formula 3 variables, 2 are known, 1 is unknown. So I can rearrange the terms and solve for the unknown, which is the payment over here. And I calculate the payment to be, this is the final answer we are looking for over here. We calculate the payment to be $8,461. So if I make 8 deposits of $8,461 at the end of each year for the next 8 years, and each deposit earning interest compounded at the rate of 8%, we will arrive at the $90,000 in the future. Let's look at part B. Robert Hitchcock is 40 years old today and wishes to accumulate $500,000 by his 65th birthday so he can retire to his summer place. He wishes to accumulate this amount by making equal deposits on his 40th through his 64th birthdays. What annual deposit must Robert make if he wishes to have that $500,000 interest earning 8% compounded? Now there's a slight catch in this. He's starting deposits today. The 40th his 40th birthday is today. He's starting today. He's going to accumulate, make the last deposit on his 64th birthday, but he's going to take the money out on his 65th birthday. So there's one additional period we're looking at over here. So future value of ordinary annuity, we know what the future value is. The future value that he wants is the $500,000. He wants to know the payments, and we have to look up the factor. Okay, now we will look up the factor, and because it's going to earn one additional interest, I'm going to multiply it by 1.12. That's to give the additional interest. I'm sorry, it should be not 12%, not 12%, it's 8%. That's my mistake over there. The formula I wrote up over there. Okay, so this will give me the final answer we're looking for. $3,348. So what was our challenge in finding out this factor? The challenge was not this additional interest. The challenge was the number of periods. How many deposits is he going to make? 40th birthday through the 64th birthday. we have 25 payments plus one additional interest calculation. Okay, so that's the only challenge. Once you know what number of periods you're looking at, looking at the table is very easy. We're looking at future value of ordinary annuity. If we had a future value of annuity due, we would not have to do this kind of calculation, but we don't have that table, so we will improvise over here. Let's look at part C. Diane Ross has $20,000 to invest today at 9% to pay a debt of $447,347. How many years will it take for her to liquidate the debt? Okay, so what we have is she has $20,000 today. We have this debt, and she's going to earn 8% interest. We are assuming this debt is not adding up any interest. The debt is what it is, this number. So how long will it take her? So I know the future value. I know the present value. Okay, so this we'll work slightly backwards over here, and I'll show you it's fairly easy once you understand what we're looking at over here. I want to pay off $47,347 in the future. I have 20,000 right now with me. That's the present value. So once I rearrange the terms, I will find the factor, and it's just solving for the equation. My factor I come up with is going to be the factor is 2.36735. Okay, now you go back to table 6.1. Let's go back to table 6.1, and we're looking at, just a second, they had told us the interest rate was 9%. So table 6.1, interest rate is 9%. Okay, we want to look for this factor. The factor is 2.36735. So 9%, go down until you find a number as close as you can to that number. So we get this over here, 2.367636. We're off by just one decimal place over here, and that's fine. So our final answer is it's going to take her 10 years, n equals 10. This is the final answer we're looking for over here. N equals 10. So when I look up the time value of money table, I see it's going to take her 10 years. So basically saying if she deposits $20,000 today, it earns 9% interest. At the end of the 10th year, she will have $47,347, and she can pay off her debt. That's obviously assuming this debt is not accumulating any interest. So whoever has loaned her the money has told her, just repay the amount. They have not asked for any additional interest or anything of the sort. So 10 years is the magic number over here. And let's look at the last one. Cindy Houston has $27,600 in debt that she wishes to repay in 4 years from today. She has $19,553 that she intends to invest for 4 years. What rate of interest will she have to earn in order to pay off this debt? So in part C, you were told the interest rate that she can get. In part D, we are saying, I know how long I'm willing to wait. I just want to know how much interest I have to earn. So again, I know the present value, I know the future value. So I can look at it either way at table 6.1 or 6.2 to arrive at the answer. I'm going to highlight all of this and show you how we would do this. Either way you do it, you have to come up with the same answer. So if I did present value equals future value times factor, the factor I'm going to look up is in table 6.2 because I said present value equals. So I look up the present value table. If I say future value equals present value times factor and then solve for it, I'll look up table 6.1. Either case, what you'll find out is when you come up with a factor and go to the appropriate table and look down 4 years, because she has said she's going to wait 4 years, you see that she has to earn 9% interest. If she wanted to make it a shorter period of time, Let's say she said she wanted to make it instead of 4, 3 years. How much interest would she have to earn? More than or less than 9%? Obviously more than 9%. If she was willing to wait a little longer, maybe she could go there for less than 9%. Okay, so we have the basic idea over here in each of these exercises. There are three terms, three variables. If two are known, solving for the third one is not a big challenge.